Basics of electricity. In this session, we will learn electrical basics such as current, voltage, resistance, power, and Ohm's law. These concepts will help in the further discussion on the electrical systems of a motorbike. In our daily lives, we engage in activities like walking, running, and such. The energy produced from the food we intake is utilized to perform these activities. Similarly, we use different kinds of equipment and gadgets in our daily life such as bulbs, television, fan, and mobile phones. The energy to operate these equipment and gadgets is called electrical energy or electricity, and it comes from a battery or through the home electrical distribution system. So, what is electricity? Electricity is the flow of electrons or charged particles through a cable or wire. As you can see, the flow of electrons or electricity from the battery produces a light which illuminates the bulb. A switch is used to turn on or off the electricity. Similarly, in motorcycles, there are electrical components such as lights, horn, and more components that uses electricity from the battery to work. Let us now look into some of the basic terms related to electricity. They are voltage, current, and resistance. We will use the example of flow of water from a tank placed at an elevation to understand these terms. Voltage. In this example, water is stored in a tank which is placed at a height and a pipe is connected to the tank for the water to flow. The flow is regulated using a knob. We all know that if the water tank is full, the pressure in the tank will be high. This pressure results in the flow of water. Similarly, in an electrical system, voltage is required for the flow of electricity. That means the voltage is the electric pressure that causes the flow of electrons or the potential difference between 2 points in an electrical field. Voltage is denoted by the letter V. Voltage is measured with the help of a voltmeter or a multimeter, and its unit is volt, denoted by the letter V. Current. If we open the knob of the water tank, water will flow through the pipe. Similarly, electrical charges or electrons allowed to flow through a cable or wire is called current. Current is required for the working of all electrical and electronic equipments. If a light bulb is connected between the battery terminals, the filament lights up because of the current. Current is denoted by the letter I. An ammeter or multimeter is used for measuring the current. The unit of current is ampere, denoted by A. The current can be classified into alternating current or AC and direct current or DC. If we observe the flow of water, we can find that the nature of flowing will be different based on the source of water. For example, the flow of a calm river is always in a single direction, but waves of a sea will be moving up and down and will flow in either direction. It is the same with electrical current. Current moving only in one direction, like the river, is called direct current or DC. In DC, the magnitude and direction remain constant. DC is generally stored and supplied from batteries. The current which changes its direction and magnitude, like the sea waves, is called alternate current or AC. AC changes the direction and magnitude continuously. It reaches the peak voltage and drops to zero and again changes the magnitude and direction. We cannot store alternate current like direct current. In our homes, the outlets provide AC. Appliances such as toaster, washing machine, fridge, most of the ceiling fans, etc. directly use AC from the electrical outlets, whereas electronic gadgets require DC for operating. In this case, a battery or an AC to DC conversion using a rectifier is used for its function. In motorcycles, AC is produced by the alternators and is converted to DC and stored in the battery. Resistance. Resistance is the factor which limits the current flow. In our water tank example, the size of the pipe causes the resistance. If the size of the pipe is big, the flow of water will be more. If the size of the pipe is small and long, the flow will be less. The same happens in the case of electricity also. If the cable or wire used is small and long, resistance will be more. Resistance is denoted by the letter R. R is measured with the help of an ohm meter. Unit of resistance is ohm, denoted by the symbol omega. A multimeter can also be used to measure resistance. Power. Power is the capacity to do work. Let us understand about power with an example of weightlifting. A person needs more power to lift 100 kilograms than the power required to lift 50 kilograms. Like that, power is required to operate different electrical equipment also differs. This is called power rating. In the motorcycle, it is important to replace defective light bulbs with equal wattage bulbs. Power is denoted by the letter P. It is measured with the help of a watt meter and its unit is watt, denoted by the letter W. It may be calculated using a multimeter. Whenever the voltage or rate of current flow increase or decrease, the power also increase or decrease accordingly. The relationship is power equals voltage times current, or P equals V times I. Ohm's law. In an electrical system, the current, voltage and the resistance are interdependent. When testing and troubleshooting an electrical system, often it is required to measure voltage, current and resistance. We can find this with the help of Ohm's law. Ohm's law represents the relationship between electric current, resistance and voltage. According to Ohm's law, as the current increases, the voltage also increases. The relationship is voltage equals current times resistance, or V equals I times R. For example, a 12-volt battery connected to a 3-ohm load, the current will be 4 ampere. This brings us to the end of this session. In this session, we have learned that electricity is the flow of electrons or charged particles through a cable or wire. Electricity has 3 properties: current, voltage and resistance. Ohm's law represents the relationship between electrical current, resistance and voltage. Thank you.